Hello folks. So last video we covered what a RAG is. Today we are building one start to finish real code, real database running on your machine by the end of this video. Think about it in this way. If you have ever used a customer support chatbot on a website that somehow knows your specific account details, or a legal tool like Harvey AI that can answer questions about a 200-page contract you just uploaded. That's the exact pattern under the hood. By the end of the today, you will have built a smaller version of the same thing in Java with Spring AI. So agenda is here. We have 6 steps: setup, running the database, ingesting the documents, writing the query, endpoint, a live demo, and then the mistakes that trip people up in the production. I will give you a real example for almost every step, because RAG tutorials tend to say abstract, retrieve relevant chunks, and that means nothing until you have seen it solve an actual problem. So we will ground this in a real one. Imagine you work at a company and support tickets keep asking the same questions. What's our refund policy for enterprise customers? And that answer lives buried in a 40-page internal handbook nobody reads. That's the app we are building today. Now, what are the prerequisites for this? If you haven't watched the RAG explained video, just go to that first. This is the hands-on sequel. So you will need a Java 17 plus Docker and an OpenAI API key. And if you don't want to pay per API call, stick around to the end. I will mention you how to swap this whole thing to run fully local and free with Olama. Now, the pom.xml. So 2 dependencies. That's not an exaggeration. Spring AI, OpenAI Spring Boot Starter for talking to the model, and the Spring AI pgvector store Spring Boot Starter for the vector database. Compare this to what RAG looked like 18 months ago in the Python world. You would be wiring up a LangChain, a separate embedding client, a separate vector DB client, and gluing them together by hand. Spring Boot's whole philosophy is convention over configuration, and Spring AI applies that same philosophy here. Add the starter and 90% of the plumbing is already done. Now, pgvector in Docker. One YAML file, one command, and you have a production grade vector database running locally. Here's why this matters in the real world. A lot of companies just Google scale once already run PostgreSQL for their normal application data. pgvector means they don't need to adopt a brand new piece of infrastructure like PyCon just to add AI search. Their DBA team already knows how to backup, monitor, and scale Postgres. That's real, practical reason pgvector has become so popular. It's AI capability without new operational overhead. So here is a command mentioned. You can just go through it, you can run it, and then next part comes to our is a configuration part. That is, we are doing an application.yml file. This is the entire configuration: your API key, the vector store settings, and the database connection. So here I have added this kind of placeholders. You can just go create a API key, and you can put that API key set it in your environment variables, as I have shown in the first video. Notice the dimensions 1536. So that's not an arbitrary number, it is the size of the embedding server. OpenAI text embeddings 3 small model produces. If you have ever wondered how semantic search products like Notion AI search your workspace feature work, this is the exact same idea. Every piece of text gets converted into 1536 numbers that represents its meaning, and Postgres now knows how to search across these numbers. Now we have a ingestion pipeline. So this is where your document actually gets into the system. The document reads the file PDF, Word doc, HTML, doesn't matter. Token text splitter breaks into chunks, and vector store dot add embeds and stores them. If we talk about a real example, then imagine you are building this for a hospital internal knowledge base. Nurses asking, what is the protocol for a level 2 trauma patient? You would not dump the entire 300 page protocol manual as one chunk. You would split it so each chunk is roughly one protocol or one section. That's exactly what's happening here with token text splitter. And it's exactly why the call out box on this side is such a big deal in practice. I have seen real rack system fail, giving confidentially wrong answers, purely because someone chunked a legal or medical document badly. Chunk size is not a minor detail. It's often the reason a RAG app is good or bad. Now, the part that feels like magic is question answer advisor. It's a one line, and it automatically retrieves the relevant chunks and injects them into the prompt before your question ever reaches the model. Think about Intercom, FinAI, or Zendesk AI agent. When a customer asks, how do I cancel my subscription? The bot is not guessing from general internet knowledge. It's retrieving your company's actual cancellation policy and answering from that. This 15-line controller is a simplified version of exactly that pattern. So now, for actually running it, you will start the app, hit your URL, like in this case we have slash and endpoint with a real question. Now, real question is what is our PTO policy? Something that only exists in the PDF I ingested, not in anything ChatGPT was trained on. So once you will hit it, you will get an answer pulled directly from our handbook. Now what happens when I ask something that's not in the document? What's the CEO's phone number? A good rack setup says I don't know, or that's not in the provider content. It doesn't make something up. That distinction, refusing to hallucinate when the answer is not there, is the difference between a rack demo and a rack system you could actually trust in production. Say for something like an internal legal or compliance assistant. Now, the common pitfalls and production tips. These are the 5 things that separate. I got a rack working on my laptop from we shipped rack to customers. Bad chunking. Like we talked about with the hospital example. Irrelevant retrieval. That's what happens when a support bot confidentially answers a billing question using a chunk about a completely different product tier. Tuning top K and similarity threshold is how you fix that. Slow ingestion. If you are a company ingesting 50,000 documents overnight for a knowledge base refresh, doing that one document at a time will just time out. Batch it. Stale data. Imagine pricing page is your RAG index that still says the old price 6 months after a price increase. You need a re-ingesting strategy, not a one-time load. No citations. This is a huge for trust. Look at how Perplexity or Bing Chat show you exactly which source backs each sentence. Returning chunk metadata alongside your answer is what lets you to do that same thing. Now, key takeaways. 5 things to remember. To starters, get you all the plumbing. Ingestion is 4 steps. Read, split, embed, store. Querying is one advisor. pgvector means zero new infrastructure. If you're already on Postgres and tuning, chunk size top K threshold is where the real engineering work lives. Long after the demo is working. Now, if this helped you, and if you want to suggest something, advise me on these videos, you can freely comment it in the comment section below. And if you find something knowledgeable, please hit like, subscribe and share with your team, especially if you have got a Java shop that's been putting off adding AI features because you thought it meant switching to Python. So next video we are going to deep dive on chunking strategies, because as you just heard, that's the thing that actually makes or breaks a RAG system, and it deserves its own full breakdown. And also I wanted to add, if you want a like a project running on your, you can directly unzip it and you can run on your local, please add your comments. Ask me in comments. I will give you my GitHub link, so from there you can unzip it and you can run in your local and you can see the results out of it. So yeah, thank you for now. See you in the next video.